All right, hour number 4, back to quant. Now what we're going to do, our second quant block here, and for the rest of the quant blocks, I think we're doing this little bit of a different thing that we're trying out. So we're going to start out with a little quiz. So going to give you 5 questions, giving you about 10 minutes to do it. And I'm going to be able to see your results in real time. So as you get into the Google form, which I think is up here somewhere, let me know if not, Abhijit. But yeah, okay. So there's a quiz. You guys should be able to see it, and you'll be able to answer that quiz. I'm going to be able to see your results, and then I'm going to try to adapt the lesson to how you guys are doing. So we'll see how that goes. A little bit of a new thing. I've got a bunch of questions. If you guys all smoke everything, I'll give you some harder questions. I've got enough to last about 2 hours. So give you guys about 10 minutes to give a shot at that. All right. Feel free to keep submitting your answers because I'm actually really curious. Again, a little bit of a test for us. Usually on these videos, we're not that responsive. Like I like to read the comments in the chat. This is the first time we've tried a quiz. We're going to be doing it, for the full 24 hours. We got 10 quant lessons with quizzes attached to it. So really interesting to see where these go and kind of how it changes the flow of the video. So I'm not seeing any struggles at all in this first one. I'm going to rifle through it super, super quickly with apologies to the 1 out of 8 people. So I got 12.5% of the live audience struggled with this one. So I'm going to move pretty quickly. The big thing on inequalities, and I'm hearing people say they hate them. Great, you're in the right place. If I had more time, I'd walk you through it in more detail. If you want more of those basics, again, over on the GMAT Ninja YouTube channel, I think Branson did this video, did a great job with it. Nice mix of kind of the foundations and the hard stuff. This one here is just a little test of the foundations is really all it is, but kind of wrapped up in data sufficiency. And again, apologies for the speed here because I want to get to the ones that more people struggled on. Again, always on data sufficiency, good hygiene. I'm just being super, super careful, making sure that I don't lose track of what's a fact. X is greater than Y. I want to know, is this true? Now, the key here is if you divide or multiply by a negative number, that changes the sign. So if you're fairly new to inequalities, you struggle with them, you can do anything you want to inequality. Treat it just like an equation. Add and subtract to your heart's content, not going to flip the sign. Multiply or divide by a positive number, not going to flip the sign. It's when you multiply or divide by a negative, the sign's going to flip on you. So what is this really asking you? Really, it's saying, well, if C is positive, then this has to be true, right? If C is negative, then it won't be true. Because if you multiply X and Y by a constant, if it's positive, sign stays the same, negative, it doesn't. So really all we're asking here is this C greater than 0? That's it. Once you catch that, we are done here. Once you know that C is greater than 0, it doesn't matter what C is. You can divide out C, or you can multiply both sides by C and get this. Answer would be yes. So statement 1, very much sufficient. Statement 2 feels like it should be worth something. It really isn't here because it doesn't really matter if X and Y are positive or negative. So they're the same sign here, is all this is saying, but that doesn't make a difference really for us. We want to know, is X bigger than Y? Without knowing the sign of C, we can't get there. So that is question number 1. Again, getting about 87% right on this one. Question number 2, we got all kinds of excitement, which is pretty cool. So I'm going to spend a little bit more time on this one. So question number 2. This is actually already really useful for me because I wouldn't necessarily have expected that the first one would be really easy for folks and the second one would be this much harder because we're probably split down the middle here roughly. So question number 2. Is X greater than 3? Oh, great. Statement 1. A little bit of absolute values in here for you. And I'm just going to rearrange a little bit here, subtract the 1 from both sides. So what is this really telling us? Look, there are ways people can handle this that are a little bit more technical. So one of the things, so answer to question number 1 for those who are asking. Question number 1 was A. Question number 2 here. Getting into inequalities and absolute values kind of layered together. Look, some of you with really strong quantitative backgrounds, really strong technical backgrounds, you know how to handle this in a nice technical way. You split it up. I'm going to speak to the people who are not from strong, I guess, quant cultures with this stuff. All of my Eastern European students always think this is really easy. A lot of my South Asian students, talking to the Americans and the Western Europeans, we don't learn this very well typically. You might be an exception, but when we grow up, we usually don't have a great approach to this. The way I like to think about this, for people who are kind of uncomfortable with mechanics, is just to kind of go, well, hey, what do I know here? Let me pretend for a second that this is an equation, just for a second, and kind of go, well, look, I know something happens here. So if I pretend it's an equation, I know something happens here where x is equal to 0 and x is equal to -6. And again, I'm not saying this is the best approach. I'm saying this is the non-technical approach for people who want to engage in the intuition here. So something happens at -6 and something happens at 0. If it's an equation, those are your two solutions. If it's an inequality, we just know that those are kind of, I think of them as critical values, not in a very technical sense. But for folks who aren't comfortable with this, yeah, this you can handle in all likelihood. Solve the absolute value, no problem. And I'm going to draw myself a little picture and say, well, I know something happens where x equals 0. I know something happens here when x is equal to, oops, wrong way, -6. So this is 0. The question is, what exactly happens? Well, now I can just kind of think through the logic of it and go, what does this tell me about x? This is going to be true if x is -100. This is going to be a true statement. So x could certainly be less than -6. This is not going to be true if x is, let's say, I did something wrong here, didn't I? No, that's right. So if x is -3, this is not going to be true. But then if x is a big positive or a positive number at all, this is still going to be true. So now I've got myself a little picture. I know that x is here somewhere. Does that mean that x has to be bigger than 3? Not at all, right? X could certainly be negative and you're out of there. So non-technical approach to the absolute values and inequalities for those of you who need it. A is not sufficient because x certainly doesn't need to be bigger than 3. You could pick numbers there too, that's fine. But I want to kind of get at the foundations that'll help you more broadly with a bigger variety of these questions. Statement 2, x squared less than 9. Now, if you're uncomfortable here, I know some of you guys are looking at this and going, yeah, no problem at all. I can just look at this and just know what it means. Again, I'm going to speak to my fellow Westerners who didn't necessarily get taught quant in a very rigorous way, myself included. Something happens here at 3 and -3, right? And I'll try to more or less line it up here. So if x squared is less than 9, what do I know? I know that x has to be between -3 and 3. Great. If that's the case, do I know whether x is greater than 3? Yeah, I do. I actually know for a fact that it is not greater than 3. The answer to my question, it's a yes/no question. And I know from statement 2 alone, I know the answer is no. So my answer is B. Question number 3. Same thing, had a lot of issues here, which is kind of interesting. Now this one's hard, and I might actually come back to it. I'm going to save this one for a little bit later because this one's pretty vicious. This one was written by Binge. I'm going to circle back to that a little bit later in the session. Let's get back to a little bit more of the foundations. Question number 4. I'm surprised by this. You guys struggled here. Question is A equal to B? Statement 1. Okay. This is important, especially if you're a little bit rickety sometimes on the getting requests to try question 3 again. Tell you what, I'll put question 3 back on the board in a little bit because that's a tough one. And I was being a little mean by putting it in the middle, but what was fascinating to me is you guys actually struggled every bit as much on this as you did on question number 3, which I find absolutely fascinating because question number 3, Buñuel, GMAT Club legend, trying to torture me. This one, not so much. This looks pretty straightforward. Here's the thing, dividing by a variable. So when we talk about kind of these inequalities, absolute values, data sufficiency questions or data sufficiency type questions, divided by variables, you should be a little careful. If I've got an inequality, that's what we're talking about in the other one. If you're dividing an inequality by a variable, you have to watch out for positives and negatives. Here, the temptation is just to say, yep, I divided by C, so A is equal to B. and I'm out of here. And half of you made this mistake, which is pretty remarkable because I think we have a pretty strong quant crowd. At least the people who are vocal right now are telling me, yeah, these questions are too easy. Hey, these questions are too easy. That's not what I'm seeing in the data. This is super interesting. What I saw is that half of you walked right into my trap here, and you decided that statement 1 is sufficient, and it is not. Why not? Think about it this way. Even if your quant skills are pretty rickety, you probably know that you can never divide by 0, right? Doesn't make sense. How do I take this pie and divide it into 0 pieces? Doesn't make any sense. You don't get a real number, can't divide by 0, right? Think about what you're doing implicitly. You divide both sides by C, what happens? Well, you don't know that it's not 0, and that's the issue. Now, here's what I want you to do. So the thing that you could do that I think would be fine if it works for you, but I don't want you to set a little alarm in your head to say, well, I'm going to think about 0. That's my solution here. Because then it's like, well, what if you happen to not think of it on a particular day or under time pressure? I don't find that to be as, I don't know, bulletproof. What I'd like to see instead here, what do we cover in hour number 2? Quadratics, factoring, exponents. Tons of stuff where you're kind of pulling things over, factoring it. It's one of the GMAT's obsessions. Tons and tons of algebra on the test, not necessarily memorable, but lots of factoring. It's one of their favorite things. They call it the F word. GMAT's favorite thing. Let's do some more F word factoring. Great. I just want that to be the habit. Just get in the habit of it. It's never going to hurt you here to say, okay, AC minus BC equal to 0. Then I can factor out the C. And now what is this saying? It's saying that either C is equal to 0 or A minus B equals 0, which is your A equals B. So we don't know that A has to be equal to Z. C could be equal to 0 here. Bottom line, don't get in the habit of dividing. Don't do that automatically. Do it thoughtfully. If you can factor instead, that's just safer. Again, not necessarily necessary, but it's going to be safer for you. So that is not sufficient. Statement 2, obviously by itself, doesn't do anything for you. C is greater than 0. What does that tell me about whether A is equal to B? Nothing. And now as you put them together, remember we're in this little world here where we know from statement 1 that either C is equal to 0 or A equals to B. Could be both, I suppose. Now, if we know that C is greater than 0, then C is not equal to 0, which means this has to be true. And your answer is C. Very interesting. So what I just learned from all that is you guys are deceiving me on the chat. And if the loud people are really confident, and I got happy on that one. Super, super interesting to me. All right, question number 5. Let me check the stats. Better on this one. So about 2/3 correct. I'll go through it pretty quickly. So a lot of what GMAT Quant is about sometimes is just kind of, I don't know, I keep using the word hygiene today. But it's kind of remembering to do the right things at the right times, which sounds kind of silly. But when you think about what happens on inequalities, there's kind of the mechanical stuff, right? You can do some algebra, you can do something mechanical. If you can do it, great. That's going to be stronger typically because you can prove something. Or door number 2 is you can kind of think about the properties or punch in numbers or kind of get to this land of intuition. Now, theme of this particular video, so this inequalities, absolute values, mostly data sufficiency, it's that ability to toggle back and forth between algebra and logic and when to use which one. So I'm aiming that at everybody. So some of you guys might have pretty weak foundations. Great, we'll cover that a little bit here. There's not a ton you need to know. Basics of inequalities, basics of absolute values, why it's a bad idea to divide by 0, whether it's an equation or an inequality. Fantastic. For people who are a little more advanced, either kind of mid-level underscore in the 40s or super advanced, even for the super advanced folks, when do you go all mechanical, do a bunch of algebra, and when do you get intuitive and just kind of think about the logic of it and start thinking about properties? That's the heart of this. It's that toggling back and forth. So I've kind of been half joking that my quant background, it wasn't necessarily super, super strong. Kind of my K through 12, I had some really, really good teachers, but by no means was I, any sort of math god. I didn't learn inequalities very well, frankly. So first time I saw something like number 5, as I kind of started encountering the GMAT, 20 years ago, I would kind of look at this. So it was x minus 5 greater than 10. And I do what I like to call kind of having a strokey beard meeting. Stroke my beard and think about this. Like, well, if x is big, then y could be small, and you just kind of go down that road of trying to think about properties and think in generalizations or punch in values and see what happens. Those are tools. Punching in numbers is a tool. It can help you sometimes. But it's so much better if I can just do something that's nice and methodical, right? And what if I can prove whether this is true or untrue? That's going to be stronger. And it looks like about 2/3 of you figured out how to do that here, and about 1/3 didn't. So very, very simple thing. Obviously, statement one alone, not sufficient. If you're not comfortable with that, you can just kind of think through it logically a little bit. Well, x would be gigantic, but depending on what y is, maybe these are more than 10 apart. If x is bigger than 7, maybe they aren't. AD's out. Same thing here, just knowing that y is a negative number doesn't really help me a whole lot if I know nothing about x. Now, putting them together, an underused tool for some people is you can add inequalities. It doesn't always feel right. The little hitch we put in this question is you can't add them like this because the mouths are pointing opposite ways. So I'm going to rewrite this and say, so I'll write this one again, x is greater than 7. Couple ways you can do this. You can multiply both sides by -1, let's say. So I get negative y is greater than 3. And I can add them up. And that's it. So answer C here. Now, quick note on inequalities. For those of you who struggle with this or don't have a great background in it, not super comfortable, you can always add inequalities. Do not subtract them. Why does it work? Think about the underlying logic. If you struggle with inequality rules and you're thinking about it that way and you're not super well drilled in it, again, as most Westerners are not, no offense to any of us. Why can't you? Well, if I say something like 6 is greater than 5 and I don't know, 5 is greater than 1, these are both true statements, right? I can add them up, and the logic is pretty irrefutable. 2 big guys bigger than 2 little guys. Think about, we're talking about adding people's weights to each other. Hey, the 2 biggest people in the room, their weights are going to add up to more than the 2 smallest people in the room. Makes sense, right? Now, what does it mean to subtract them? Obviously, you get garbage here, not a true statement. Why is that? The difference between the 2 biggest, let's say these are people, and it's their ages, the difference in age between the 2 oldest is bigger than the difference between the 2 youngest. That doesn't make any sense. Why would that be true? It doesn't need to be true. Don't subtract them. You can add inequalities. There's a ton of questions where that bails you out. And if you do it some other way, it can get really, really, really hard. So there's a number of questions we can point to. I might do one more later on in this hour. All right. That was number 5. Where would I like to go with this next? I'm going to skip around a little bit through my notes. I'm going to do 2 more that I think are kind of moderate in difficulty. Punchlines. One of the things I'm getting a lot from kind of the live crowd today, how important is this stuff? What we just covered in these 4 questions. So I covered questions 1, 2, 4, and 5 from that little mini quiz. And I'm going to come back to number 3 in a little bit. We'll circle back to number 3 because it's harder. These foundations that we put into 1, 2, 4, and 5, these are all things that, yes, you need to know. If your goal is something like a 45, 47 plus, you want to get a 700 plus, you need to know this stuff. You need to know what you can and can't do with inequalities. And this is it. It's pretty much the end of the rainbow. It's you can add inequalities. You can't subtract them. Watch your back if you're dividing by variables. If you divide by a negative, it flips the sign. And sometimes visualization really helps you, especially when it's absolute values mixed with inequalities. That's really it. There's no more foundations than that you really, really need. We can get all fancy. There's textbooks written about inequalities. Don't need it. These foundations are all you really need. Kind of on the one equation we had in there. Again, just watch your back, especially on data sufficiency, dividing by variables. If you don't know it's 0, you can't do it. Better hygiene. Pull it over to one side and factor it. All right. We will come back to number 3 at the end because it's a tougher question. I want to get to more of kind of the foundational stuff first and see what you guys do with it. Let's do this. Okay, this is fantastic. We're getting huge variation here, which is exactly what I was looking for. All right. And I've seen people come up with really good punchlines in the chat, which is great too. So kind of one of the big punchlines of all the stuff we've been talking about so far, inequalities and equations. Don't divide carelessly, I think was the way somebody put it, and I apologize, I didn't catch the name. But yeah, that's exactly right. Don't divide carelessly. Be thoughtful when you do it on the GMAT, especially in data sufficiency. If you're dividing by a variable, it's an inequality. You risk flipping the sign. If it's an equation, you got to think about 0. It's not to say you can't divide by variables. I'm not saying that at all. I'm saying do it thoughtfully. Make sure your head's in the game. And again, the question is, how do avoidable errors happen? These are some of the ways, right? You're just dividing on autopilot without thinking about what those numbers really mean. So here, I've got somebody made an interesting comment, like it is better, maybe it's better to be mechanical here. Sorted true, sorted not. It depends on what we mean. Blind mechanical, bad. So here, if I'm being blind mechanical, that's a weird term, but I'm going to go with it. I divide both sides by A. What do I get? I get AB is less than 1, and I win. That's sufficient. I can do the same thing here and get AB less than 1 again by dividing by B. And I win again, and the answer is D. And I think first wave of folks got a lot of Ds. But again, dividing by a variable at inequality. 0 is not the issue here. I know that A is not 0, or else it's not an inequality. But I do know that A could be negative. It's possible, right? So if A, here's what happens. If I divide by A, this is true if A is positive. But it goes the other way if A is negative. I don't know whether A is negative or positive here. So A is out. Same exact thing on statement 2, divide by B. Yeah, I can get AB is less than 1 again. That's if B is positive. And same thing again, that's if B is negative. So very, very symmetrical so far, for better or worse. So it's not B either. Now, as we put them together, a bunch of ways we could do this, a whole lot of different ways to go about this. I'm not going to go through all the different ways. But I'm getting some arguments here that you can be mechanical about it. I'm down with that. I don't think that's a bad way to do it at all. You can kind of think through the logic of it and come to the same conclusion. Totally comfortable with that. I'm going to show you the algebraic way. Again, not the only way. And I'm just going to add these inequalities again and see what happens. So a squared b plus ab squared is less than a plus b. Remember, GMAT's favorite thing in algebra, and you're going to hear me say this a lot today, arithmetic and algebra, more than half of your test on quant. We all obsess over things like rates and probability and even geometry because it's visual. But look, half your test is going to be arithmetic and algebra in different forms. We can split hairs over those definitions. It includes a bunch of things. But this is not memorable. You walk out of your test, and if you walk out of your test, you go, oh man, I underperformed by 5 points on my quant. I'm disappointed. And I say, well, what'd you struggle with? You're not remembering this. It's not memorable. This doesn't stick, right? But it's such a huge backbone of the quant section. We under focus on this stuff typically as GMAT students. So all that algebra, what's their single favorite concept in algebra? It's factoring, right? All those quadratics we worked on, all those exponents we worked on. F word, once again, I'm going to remove the AB here. Take out the AB, I get A plus B less than A plus B. Oh, hey, I could divide by A plus B again, but same thing we got into up here. I could divide by A plus B, but I don't know whether it's negative or positive. So we end up getting the same thing over and over again, is that AB could be either less than 1 or greater than 1, depending on whether A and B are positive. So your answer here is E, party on. All right, buddy, having fun? I'm going to ramp up the difficulty a little bit here. Let's get a little more conceptual with this one. How much time do we have? We got 20 minutes. All right, I'll give you guys a couple minutes on this question. And this is, yeah, going to be fun. All right, now we're getting to the other part of your brain. So first half of this hour block, I was talking about here's the foundations you need. I want you to think about what you're doing when you're dividing. I want you to think about what inequalities are really doing. Here's some tools. You can add inequalities, don't subtract them, that kind of stuff, right? Now we're kind of into a different part of your brain. You can't just algebra your way through this. I just used algebra as a verb. I'll go with that. You can't algebra your way through this completely. You've got to be able to think back and forth between logic and algebra. Tons of different approaches to this. So what I'm saying isn't necessarily the only way or even the best way. This is what I think is the easiest to explain, especially if you struggle a little bit on this. I want to do my best. I talk about pushing the question a lot on data sufficiency. How can I reframe this in a way that I can get my head around? So absolute value of X is less than 1. If you want to draw a picture, knock yourself out. You can do the same thing we did before if that's your thing. Where I go, hey, I know something happens at 1, something happens at -1. If you like this tool, go for it. What do I know? Well, the question is asking me, is X between -1 and 1? Put another way, you could say, is X a fraction of some sort? I'm great with either one. I'm great with you saying something like this. Draw yourself a picture and say, is X here? That green marker needs to go away. Is X here in this zone? Great. I would probably reframe it as, is x a fraction? It can be positive or negative. Whatever works for you, whatever keeps you anchored in that intuition. And again, it needs to be a translation of what the question's asking you. Don't take it for a walk. Make sure that it's something that means the same thing. The answer is yes, if x is a fraction, positive or negative. So between 1 and 0, positive, or between 0 and -1. The answer is no if it isn't. Great. And again, if the visual helps you, go for it. This is spot on. This is about as beautiful as it can get. I didn't see a lot of people. I think pretty much everybody was getting that it was either A or D. We've had some exceptions. But what is this telling us? Well, we know that x isn't 0 anyway, so that's great. Yeah, if x squared is less than 1, then x has to be either a positive or negative fraction, right? The squared is going to sanitize out the negative, if there was one to begin with. So yeah, this is saying exactly the same thing. If it helps you to draw this out, also knock yourself out. So A is sufficient. Could cross out B, C, E. Now this guy, this is the tough one. And this is where we really get into kind of that other levels of thinking. Not levels as in higher or lower, but just different way of thinking, right? Like I have this impulse still to multiply both sides by x. Why is that a bad impulse? Well, until I do a little bit of thinking, I don't know if it's positive or negative. Bad idea. Hopefully none of you guys did that exactly. So I got to come at this from a different angle. If I can't just look at it and go, I'm going to start multiplying stuff, I've got to think about it in some other way first. So I'm going to put my logic hat on and go, well, what do I know? I know that this side's positive. We know x isn't 0, so this has to be a positive number. So the absolute value of x would be positive. Now, if 1 over x is bigger, then that's telling us that x has to be positive. If x is negative, this isn't a true statement. So now I know that x is positive as well. And now I'm in business, right? Now I can just multiply. And this is the toggling back and forth between algebra and logic that I was talking about. I use a little bit of logic to make me go, okay, I see the properties here. I see they're both positive. Now I can just rearrange x times absolute value of x less than 1. The absolute value sign doesn't really matter here anymore because x is positive anyway. So you could rewrite it if you wanted to as x squared less than 1. And that's it. You got it. Now that's D because it's saying exactly the same thing as statement 1. Party on. How much time we got? We got 10 minutes. Let's go back to Buñuel's madness on question number 3. And let's see how that goes for it. Same kind of thinking. And I'm getting some questions and everybody caught it. The reason why we know x is positive here, left side of the inequality, positive number. X might, we don't know necessarily right off the bat whether x is, but whether x is negative or positive, left side, absolute value of x has to be positive. That means this side has to be positive, which means x has to be positive. Welcome to GMAT. All right. Next question. Let's go back to Buñuel's madness in question number 3. Good luck to you all. Really enjoyed the comments on this one. This is nasty. But to be fair, I don't. You guys know how much everybody admires Buñuel. You know, he bear hugs are actually what he gives bears. He's amazing. But what I find fascinating about his questions, you're going to see plenty of them today. Is it really hard? And he combines a bunch of things and pushes it kind of maybe to a limit or past a limit or something like that. Yeah, you bet. But all the components of it, you bet. I mean, these are all things. It's like he kind of took the things that you see on the test all the time. This kind of thinking about like, wait, let me think through what's happening to the sign. Let me think about the properties of it. Think logically, and he's just, you know, making that just exponentially not harder, not more complex exactly, but just layering it a way that you really have to think. So this is a GMAT club test question, by the way. So if you haven't tried out those tests, great if you really want to challenge yourself on quant. Buñuel wrote most of them. All right. So we're going to start here. I know that both of these numbers are negative. So x is less than 0, y is less than 0. And now it's just kind of a question of following my way through and sort of thinking about, what do I know? What happens here? I'm going to start over here on this x squared thing that's underneath the root. Now, if you're really well versed in this stuff, you might look at that and just know that that sanitizes the negative. So if x is negative, we square it. Now it's positive. We take the radical positive. If it's positive, obviously you're going to get the positive anyway. So what is that doing? This is not x, but it's the absolute value of x, right? And I'm going to write it that way for now. absolute value of x over x minus, now what do I do with this thing? Well, negative y, that gives me a positive number. This thing's a positive version of y as well. So hey, wait a minute. Now this is exactly the same thing as that, right? We're taking y, we're multiplying it times itself, we get a positive, we take the radical of it. So what I get here is the positive version of y. So this is essentially y squared, y squared square rooted. I just get not y, absolute value of y. So positive number there, absolute value of y is going to be positive, y is negative, but the absolute value is positive. So positive times positive, we just get y squared, square root it, absolute value of y. Okay, not so bad. Looks better now. Let me think about this. Positive, negative. So what do I have here? I mean, obviously x divided by x is just 1, but I've got negative 1. Got to be, right? Because top part's positive, bottom part's negative. I hear they have fancy terms for bottom and top. I guess they call them numerators and denominators. Anyway, I'm going to say top and bottom. I'm getting sleepy. Top, positive, bottom, negative. This is negative 1. Now this. So this thing, the absolute value of y, positive. Y is negative. Absolute value is positive. So we could rewrite this as minus y. Think about that for a second. Positive number, positive version of y, positive version of y. And now we're there. Those negatives are going to turn into a positive. Minus 1 plus y, y minus 1. And that's our answer. Answer is D. Party on. Okay, quick little bit of context. I'm getting people wanting to jump off a bridge from this one. Fair enough. This is not a question you need to get right. Depending on what your goals are, you're going for a 51 or something like that. You have a really compelling reason to do it. Great. But look, when you think about kind of the admissions process, what is if you're going for an MBA? Think about the admissions process. What are they going after? We want to see a nice composite. We want to help out the averages and all that kind of stuff. We want to see good enough quant, get above a 47. You're usually fine depending on your background. You don't need to get a 51. You're applying for a PhD in something or master's in finance, different conversation. But this is kind of a blow your head off kind of question. So if you didn't get this right, no shame at all. If you did get it right, congratulations, because this is tough. Having a little bit of fun with you here. But the one point I will make about it, those first 4 questions we went through, yes, those foundations of how to manipulate inequalities, the foundations of why you need to be really thoughtful, mindful when you divide by a variable, absolutely crucial. Your goals mid to high 40s even, crucial. Let's get there. That stuff really matters. The ability to toggle next level from that, the ability to toggle back and forth between algebra and logic, also super, super important. You're going to see that all the time. The better you can get at that, better off you're going to be. Now, this is just combining it into so many pieces. It's going to be combined into so many pieces that that's what makes this one hard. And if you didn't get it, no shame in that at all. I'm actually hearing from the comments that oh, that's interesting. Okay, so that got dropped off the slide. So on the original version of this question, I apologize for that, guys. So when this slide was made, so the original question actually reads, if x and y are negative numbers, let me pull it up on a different slide. Not in there, never mind. Okay, it got removed from the slides. Apologies for that. But that's actually, and I don't know how it got removed. It actually says in the original question, x and y are both negative numbers. So apologies for that. In our haste to get these slides put together, I think that got dropped off. So in case you just watched all of that mess and you're going, how did you know these guys are negative? I apologize. The original question Buñuel wrote says they're negative. That's what you're going to see on the GMAT Club forum. That's what you're going to see on the tests. That's what's in my notes. That's Buñuel's intent. Apologies for the typo on that slide. So that might be some of the stress that's happening here. And I apologize for that. Because people are asking, like, how did you get that? It was in the question, but apologies. That was a transcription error apparently this morning. Okay. Sorry for the slide goof up. This is what we get. 24 hours of mayhem. That's our first epic error. Apologies for that, everybody. Okay. One last pitch, aficionado, and I think I was a little cagey earlier. So answer on this one, by the way. This is it. This is answer choice D. you get your Y-1 on this particular question. So Emissionato, very, very quick story, because again, I super appreciative of the sponsorship and all the support for this. I hope she won't mind, but there's a consultant there named Julia Hazen. Just to make this a little bit more personal, I was telling a story earlier about rescuing at the last minute one of my favorite guys, procrastinated his applications, lovely, lovely fellow. He was a total mess. Last minute, I'm yelling at him on December 20th for January 5th deadlines. Julia took him in, got him in Wharton. Some great people over there at Emissionato, and hugely, hugely appreciate it. And thank you again, guys, for the sponsorship.